Welcome! Today you are learning to visualize data using Pandas. This lesson uses the tips dataset about restaurant bills and tips. You are going to create line plots, bar plots, histograms, and box plots. Visualizing data with Pandas, line, bar, histogram, and box plots. In this lesson, you are going to explore simple but powerful ways to visualize data using Pandas. We will use the tips dataset, which contains restaurant bills and corresponding tips. By the end, you will know how to quickly create line plots, bar plots, histograms, and box plots for your own data analysis. Running the cell now. Let us get started by loading our example data. First, you will set up the environment and load the data. This imports the warnings library to help us filter any warning messages. Here, warnings in the notebook are turned off to keep output clean. Now, let us load the tips dataset from Seaborn. We import Seaborn, which includes several example datasets. Import NumPy as NP. We set the random seed to 42 for reproducibility. This command loads the tips data into a data frame called df. This prints the number of rows and columns in the data. This prints a sample of the first 3 rows so you can see what is inside. Running the cell now. The output shows that the tips dataset contains 244 rows and 7 columns, indicating a moderate-sized dataset with attributes like total bill, tip, and customer details. This preview helps you confirm the data structure before creating visualizations to explore patterns and relationships in the restaurant tips data. What patterns do you expect to see in bills or tips? Try to predict. Let us briefly look at the columns in the dataset. Quick data overview. Let us examine what is in the dataset. Notice the following columns. Total_bill, the total restaurant bill, including tip. Tip, the tip amount given by the customer. Sex, the gender of the bill pair. Smoker, whether the party included smokers. Day, day of the week. Time, lunch or dinner. Size, number of people at the table. Running the cell now. Think about which columns might relate to each other and why. Let us check if there are any missing values in the dataset before plotting. This line checks if any data is missing, which is important before you analyze. This line prints the count of missing or null values in each column. Running the cell now. This output shows the count of missing values in each column of the dataset, with all columns reporting 0 missing entries. This confirms that the total_bill and other features are complete, allowing us to proceed confidently with analysis without needing to handle missing data. Checking for missing values is a crucial first step in getting a quick, reliable overview of the dataset. If you see zeros, that is great news. If not, you may need to handle missing values. Let us take a quick look at summary statistics for the numerical columns. Let us add up some general statistics like the average, minimum, and maximum for our numeric variables. This prints summary information for columns such as total_bill and tip. Running the cell now. This summary gives a quick statistical overview of key columns like total_bill, tip, and size, showing counts, averages, and ranges. Notice the average total bill is about $19.79 with a typical party size of around 2.5 people, which helps us understand the dataset scale before deeper analysis. This step ensures we grasp the data's central tendencies and variability as we explore restaurant bill behaviors. These values can help you spot unusual bills or tips. Let us create your first plot using Pandas, a line plot. Your first plot, line plot of total bill. Line plots are great for displaying continuous data and trends over an index. Let us try plotting restaurant bills in the order they were recorded. Running the cell now. Are there any big spikes or dips you notice in the graph? You will now plot a line chart using the total_bill column. This line of code creates a line plot of the total_bill column from the data frame, showing how the total bill amounts vary across entries. Running the cell now. This line plot shows the total bill amounts in the order they were recorded, allowing you to observe trends or fluctuations over time. Notice how each point represents a bill, connected to highlight changes across entries. This visual helps you understand patterns in continuous restaurant data using simple plotting commands. Try plotting a line plot for the tip column as a quick practice. Let us plot a line chart for the tip amounts next. A line plot of the tip values helps you compare with the total bills. Again, this shows changes across entries and finds higher or lower tip values. Running the cell now. This line plot shows the tip amounts in the exact order they were recorded, helping us see how tips vary over time or entries. Notice how the points connect smoothly, highlighting trends or fluctuations in tipping behavior throughout the dataset. This visual confirms how line plots effectively display continuous data sequences, which was the goal of this section. How does the tip amount vary compared to the total bill? Discuss what you see. Now, let us move to a bar plot for comparing category data. Bar plots, comparing tip amounts by day. Bar plots are ideal for comparing quantities across categories. For example, let us compare the average tip amount by day of the week. Running the cell now. Which day do you think receives the highest tips? Make a guess. You will now create a bar plot to display average tips for each day. We start by grouping the dataset by the Today column and calculate the mean tip amount for each day. Then, we create a bar chart to visually display the average tip for each day, with a title and y-axis label for clarity. Running the cell now. This bar plot visually compares the average tip amounts given on each day of the week, showing clear differences in tipping behavior across days. Notice which bars are taller, indicating higher average tips, helping us quickly identify trends that might be linked to factors like day-specific crowds or service expectations. This aligns with the lesson's goal of using bar plots to effectively compare quantities across categories. Think about why some days might have higher tips. Is it busier? Let us try a different bar plot, looking at the average total bill for smokers versus non-smokers. This line is a comment explaining that we will create a bar plot for the average total bill by smoker status. This line groups the data by smoker status, calculates the mean total bill for each group, and plots the result as a bar chart with titles and labels. Running the cell now. This bar plot shows the average total bill amount separated by smoker status, highlighting the difference between smokers and non-smokers. Notice the height of each bar reflects the mean bill, making it easy to compare these two categories. This reinforces how bar plots effectively summarize and compare quantities across categorical groups, just as we did earlier with tips by day. Can you think of another column to group by? Experiment and see. Now you will learn about histograms. Histograms, distributions at a glance. Histograms provide a quick summary of the distribution of a numerical column. Let us look at how total bills are distributed. Running the cell now. Try to guess whether bill values are mostly small, large, or evenly spread. Let us plot the frequency of different bill amounts with a histogram. This line adds a comment describing the histogram of the total bill. This line creates a histogram of the total_bill column with 20 bins, showing the distribution of bill amounts. Running the cell now. This histogram shows the distribution of total bill amounts in the dataset, with 20 bins dividing the range of values. Notice the shape of the distribution, whether it is skewed or symmetric, and any common ranges where bills cluster. This visual helps us quickly understand spending patterns before diving deeper into the data. Try changing a bins to see how it affects the look of the plot. Let us check the distribution of tip amounts now. This line is a comment describing that the plot is a histogram of tips. This line creates a histogram of the tip column in the data frame to show the distribution of tip amounts. Running the cell now. This histogram shows the distribution of tip amounts, revealing how frequently different tip values occur in the dataset. Notice the shape and spread. Most tips cluster around certain amounts, which helps us quickly understand tipping behavior. This visual summary is exactly what histograms provide, making it easier to identify common values and overall trends in numerical data. If you see a long tail on the right, it means a few people tip much more. Finally, let us learn about box plots for summarizing and comparing groups. Box plots, summarizing data and outliers. A box plot summarizes key percentiles and highlights outliers. Let us draw a box plot to compare total bills by time of day, so dinner versus lunch. Running the cell now. Think about what the box and dots tell you about the spread of bills. Let us draw box plots for total_bill split by time. This box plot compares the distribution of bills for lunch and dinner. Running the cell now. This box plot compares the distribution of total bills for dinner and lunch. Notice the median, interquartile range, and any potential outliers in each time category, which help summarize spending patterns and highlight unusual values. This visualization reinforces how box plots efficiently reveal differences and variability between groups. Do you see much higher bills at dinner or lunch? Now, compare tip amounts for different table sizes. Create a box plot to compare tip amounts for different party sizes. Use the DataFrames boxplot function to plot tips grouped by party size without a grid. Running the cell now. This output shows that a box plot was created to compare tip amounts across different party sizes. Notice how the plot groups tips by the number of guests, illustrating how the tip distribution changes with party size, including medians and potential outliers. This helps understand spending behavior similarly to how we analyze total bills by time of day in the lesson. Let us see if the tipping behavior changes with larger groups. Now, combine multiple plots into a single figure to view patterns side by side. Bringing it together, multiple plots in one figure. You can show several charts together to compare trends or patterns. Let us use Pandas to create a 2x2 grid of line and bar plots. Running the cell now. Combining charts helps you tell a data story visually. Try your own custom grid. Let us set up multiple subplots and display several types of charts together. First, we import Matplotlib so we can customize plot layouts. Here, we create a grid of 2 rows and 2 columns for our charts. This puts the total bill line chart in the upper left panel. This adds a tip line chart in the upper right corner. Here is a bar plot of average tip by days on lower left. Finally, we display a histogram of total bills in the bottom right. Tight layout helps ensure all charts are neatly arranged with readable labels. Running the cell now. This figure arranges for different plots in a 2x2 grid, allowing easy comparison of key aspects of the dataset. The top row shows trends over the dataset with line plots of total bills and tips, while the bottom row highlights average tips by day with a bar chart and the distribution of total bills with a histogram. This layout demonstrates how combining multiple plot types in one figure can provide a comprehensive view of data patterns and relationships at a glance. What new insights do you find when viewing multiple charts at once? Try creating your own plots now for extra practice. Challenge: try your own plots. Create a histogram for the size column. Or, make a box plot showing tips by gender. Remember, use .plot kind equals with different kind values. Pause and experiment for a few minutes. Running the cell now. Feel free to share your favorite chart in the comments below and subscribe for more tutorials. Let us finish by saving one of your plots as an image file. We will produce a histogram again, but this time save it to a file. First, the plot is created and stored in a variable. Next, we access the plot's figure object. Finally, we use savefig to store the image on your computer as total_bill_histogram.png. Running the cell now. This output shows a histogram of the total_bill column, which helps visualize the distribution of bill amounts across the dataset. Notice how the bins equals 15 divides the data into intervals, revealing patterns like clustering or spread. Saving the figure as an image file connects to the lesson's intent by demonstrating how to create and preserve visualizations for reports or presentations. You can use this method to save any chart and share your findings. Great job! Let us review what you learned today. Recap what you learned. You created line, bar, histogram, and box plots using Pandas. You learned how to quickly explore patterns and outliers in real data. Try using these plot types anytime you work with your own datasets. Happy coding! Running the cell now. Which chart do you find most useful? Practice with your own data for deeper learning. You did it! Here is how to keep learning and contribute. Next steps: join the community. If you liked this lesson, subscribe for more practical data science. Comment which other plots or datasets you want to see next. Keep exploring and visualizing new ideas. Running the cell now. Thank you for learning with us. We hope to see you in the next lesson.